Okay, listen to this question. Which of these formulas would you use if you, which of the formulas would you use if you knew what the first term was, they told you what R was, and they told you what the sum was? They didn't tell you how many there were. You know what the sum is. You know what R is. You know what the first term is. What color would you use? Could you use green? Could you use green? Green is used, I said R, so geometric. Green is used when you're trying to find a specific term. Like if I said, you start with 8, R is 2, let's go to the 8th term, right? You would plug in 8 for n. Green isn't used to find a sum. Let me repeat the question. Which would you use if you knew what the first term was? Let's say you know U1 is 2. You also know what R is, 0.8. You also know what the sum is, but we don't know what term number it is. What I'm doing is 4b. So you need to know, great, I gave you the formulas. If you have no idea when to use which one, what good are the formulas? Nothing. You don't know how to use them. You're not going to have time to use every formula for every problem and then guess which one applies. You have to know which one to use. So right away, when you see the R, who can we eliminate? Blue. That goes with arithmetic. Who else is out? Red. That's the explicit formula for an arithmetic. If I'm trying to ask which term number it is, then it's not infinite. So this is out. That's only for infinite ones. So it's between black and green. If we used green, we know what U1 is. We know what R is. We don't know what N is. And do we know what the nth term is? We don't know what N is, so we don't know what the nth term is. If you don't know whether you're on term number 8 or term number 9, you can't figure out what the answer is, right? What we need to do here is figure out this. What are they giving us? What are they telling us? They're telling you what the sum is. So we're not going to use the green formula. If they're telling us what's that thing? Sum, we should probably use the formula with the sum in it. What is the sum? What is U1? Times 1 minus, what's R? 0.8 to the n over 1 minus 0.8. And it's time to stop getting that little anxious butterfly in your stomach when you realize, oh, I'm solving for n. That means I need a log. I need an exponent. Who cares? Logs are easy. Get past the fact that it's a new concept. We learned it. Logs are no problem. Let me show you how you would use a log to get n in this problem. First of all, what's on the bottom, on the right side? Negative, right? Over 1 minus 0.8 is positive 0.2. Just kidding. Okay, so how would you get rid of that 0.2? Go. Multiply both sides by 0.2. So we get 1.34464 because we multiplied both sides by 0.2. You know the next step in solving this equation. Divide by 2. Point equals 1 minus 0.8 to the n. Take away 1. Are you going to get a negative on both sides right now? Equals negative 0.8 to the n. If both sides are negative, cancel it. It's a fancy way of saying divide both sides by -1. So we don't want to have negatives when we go to do a log. But now it's time to use a log. And using a log to solve a problem should be, at this point in your mathematical career, as easy as saying multiply both sides by 2. Take the square root of both sides, square both sides, log both sides. Instead of rewriting it as a log, you could log both sides. Or you could rewrite it. Log, what's the base, of equals the exponent we're looking for, n. If you have the log base formula on your calculator, use it. If you don't, you do the log of the big font number. You know why I say big font number and not big number? It's not necessarily a bigger number. It's the larger font, okay? Divided by the log of the base. It's actually the log of the argument divided by the log of the base. And you get 5. What does that mean? That n is the 5th letter of the alphabet? No. That 6.7232 was the sum of how many terms in this sequence? 5. 5. We realized it was S5. It was the sum of the first 5 terms. That's it.